Right, so just separating the data into different categories can give us some different information. So if, for instance, I was doing my Honda cars internal, I could insert a scatter graph, tidy up your axes and whatnot, but importantly here, I'm just going to right-click and add Trendline. And remind yourself again, if you haven't done this before, I want to pay really close attention to what's going to be my best trend line. So here you notice that I see some points above, I see a lot of points down below, and I mean, think about the real life situation here. This is predicting the price of a car. That straight line is going to keep going down. It's eventually going to become negative. That doesn't really make sense to me. So let's try something else. Really the only three you want to play with would be exponential, or log, or linear. And here if I look at the log, yeah, it decreases rather steeply at the start, kind of starts to level off, and that makes a bit more sense to me because a log graph will level off. So I'll use that, and you can set your equation on there. Do not use the R value because this is a nonlinear graph. So one of the things that you can do from here is go ahead and make predictions and whatnot, but as is role modeled in the exemplar, we can actually also look at splitting this data out because it comes in a few different categories. So we could decide whether or not there's a different fit for the number of doors in the car, or for whether it's manual or automatic, if there's a better resale value from one or the other. One of the things that we can look at is where it's assembled, and so we can compare Japan versus New Zealand. So number 1 is for New Zealand, number 2 is for Japan. And I want to show you how to make this graph so you can see those two individually. So first thing for us to do would be this idea that I want to go ahead and sort all my data. So if you just highlight everything, we can go to sort. Should find it somewhere in data, somewhere on your computer, depending on if you have a Mac. Just find the funnel and sort, and you can do a custom sort here. Your data does have headers, so tell it that. And basically what that says is it's going to look for the titles up here. So I want to sort by assembled to see where it is actually assembled. Oops. Sort by assemble. And smallest to largest is fine. You can also change that largest to smallest. Click OK, and you'll notice now, as you look at my data, it starts at 1s and then goes down to 2s below. So the first reason I've done that is because now I can actually highlight it a lot easier for those that are in New Zealand and those that are in Japan. My next little trick here is that I might actually just get rid of this data set. You could delete that column. Another trick for you would be to move it. And the only reason I want to move it is so you get those 4 crosshairs, you can just drag it over. Yeah, okay, replace it, why not? You could copy and paste, and you can always go back to your original one if you want to know what doors are. But I just want to put them next to each other because it makes it easier to highlight. So I'm going to highlight for the first group, and I'm going to go down and stop where I've got all the cars assembled in New Zealand, so all my 1s, and then I'm going to stop. I'm going to go ahead and insert scatter graph, new graph. You can see it's not all the same points that we had on the other graph. Okay. And next thing that I'm going to do then is, of course, format my axes and my titles and all that, and you should see that in chart layout. But I want to get the rest of the points on there. So that's again just the New Zealand ones. If you right click, you should be able to find select data somewhere. If you didn't find it, try right clicking somewhere else, or just clicking. Oh, now it's freaking out. Select data. And here I want to add more data, so I am just going to select the rest of them that have a value of 2. So first thing I need to do is actually add a new sequence. So I can say this one is the Japan model, the ones that are made. If you click here, it allows you to select the X values, which in this case was the kilometers driven. Press enter, and for the Y you want to delete that away and select the Y values, which would be this part of the graph. Right, that's Miss Fogarty. Press enter. We've got both of these things in here now. You can press OK and press OK. And if we come back up and look at our graph, look at that. Whole new set of data points in there. So now you can see everything, like similar to what we had before, but you can see the ones that were made in Japan and the ones that were made in New Zealand. And now you can actually add a trend line to these separately. So if you right click on the blue points, you can add a trend line. And again, you've got the option to put your r squared value on there. And put that someplace. And the next thing you could do, of course, is right click on the red points. Hopefully. And do trend line. Similar. And display the equation on the chart. And actually, sorry, I hadn't done that on the other one, but we want to play with this. You know, again, is linear the best one for it? Quite possibly not. So we could put logarithmic back as our choice. And so this is the logarithmic equation for cars made in Japan. And if you want to change that again, just click on the other trend line and you can see those are the options there. Of course, if you're on a Mac, you need to click on your trend line and go into options, and then you can select what you want inside of there. But here you can see my equation is now changed to a logarithmic one. And so that's actually really close. If you look, oops. If you look at the price, just in general with New Zealand and Kiwi cars here, I have the equation here is negative 8.23 lnx plus 47, roughly. And this one's still pretty close. It's negative 8.1 lnx and plus 48, so it's actually fairly similar. But you'll notice this one for the cars that are made in Japan is actually quite different. So what you can talk about here is that if I was going to make predictions and I knew whether I was predicting for a New Zealand car or for a Japanese car, you can decide which equation you were going to use. So you might have a better prediction, have like a more accurate prediction if you use an equation that is specifically for that data. And just to show another example of this, this is the exemplar for the bones, do dead men tell tales, looking at forensic data. So here we've split the data out into different ethnicities. We've got African, Asian, and Caucasian ethnicity, and you can see that depending on which ethnicity you are, you can actually fit a slightly different trend line with relatively good R values as well. So you can get a trend line overall with all the different ethnicities mixed in, and it's still pretty strong. Take the square root of that, you'll get a pretty strong R value. But here you can see, if you color them out, you can actually see they do follow slightly different trends, and that's not surprising. With genetics, the ratio of our, for instance, leg length to height might be slightly different. So that's an example of where it might be helpful or powerful to have data separated out into different categories that you can use to make predictions.